Hello and Assalamualaikum. Today our group will present Chemistry Form 4 Chapter 7 Rate of Reaction. We will discuss about two factors which are size and concentration of reactants. First, we will talk about size of reactant. The small size of solid reactant has a large total surface area. The total surface area are exposed to collision between reacting particles increases. So that the larger the total surface area of solid reactant, the higher the rate of reaction.
The next one is concentration of reactant. The solution of higher concentration and gas under higher pressure has higher number of reactant particles per unit volume. The reactant particles collide more frequently. Hence, the higher the concentration of aqueous solution, the higher the rate of reaction. Collision theory. What is collision theory? Collision theory is when two different reactants are mixed, then the reactant particle will collide with each other. During these collisions, the chemical bonds in the reactants break apart and form new chemical bond in the product. But not all of these collisions will result in product formation.
Now we want to relate the frequency of effective collision with factors influencing the rate of reaction. First of all, the factors is size of reactants. A decrease in size of solid reactant causes an increase in rate of reaction. Solid reactant with smaller size has larger total surface area exposed to collision. When the total surface area of a reactant particles increase, the total surface area exposed for collision to occur increase. And then the frequency of collision between reactant particle A and B increase. As a conclusion, probability of collision in correct orientation increase, hence the frequency of effective collision increase.
Lastly, concentration of reactants. Solution. The first one is an increase in concentration causes an increase in rate of reaction. Next, the solution with higher concentration have a larger number of particles per unit volume. Other than that, frequency of collisions between reactant particles A and B increases. Last one, probability of collision in correct orientation increase. Hence, the frequency of effective collisions increase.
Question 1A. Two experiments were carried out by a student to investigate the factors that affect the rate of reaction between the metal Y and the acid. Table 7 shows the reactants and the time taken to collect 30 cm³ of hydrogen gas released. 1. Name one example of metal Y and one example of the acid. By using the metal Y and the acid name, write a balanced chemical equation for the reaction occurred.
One example for metal Y is magnesium, while example for acid X is nitric acid.
2. Calculate the average rate of reaction for experiment 1 and experiment 2.
Back to the question, these reactants collect 30 cm³ of hydrogen and the time taken for experiment 1 is 10 seconds, while experiment 2 is 20 seconds. So, the formula for average rate of reaction is volume divided by time.
3. Compare the rate of reaction between experiment 1 and experiment 2. Explain your answer by using the collision theory.
Size of metal Y in experiment 1 is smaller than in experiment 2. As you can see, total surface area of metal Y in experiment 1 is bigger than experiment 2. Frequency of collision between magnesium atom and hydrogen ion is higher in experiment 1 than in experiment 2. Frequency of effective collision in experiment 1 is higher than experiment 2.
The table 2 shows the information for experiment 1 and experiment 2 to study the rate of reaction of zinc with two acid P and Q.
A. First Roman, state the name of the acid used in the experiment 1 and experiment 2.
The acid P is a nitric acid and the acid Q is a sulfuric acid. It is because the product of experiment 1 is a zinc nitrate, while the experiment 2 is a zinc sulfate.
The second Roman is write the chemical equation for the reaction of acid P with zinc and calculate the maximum volume of hydrogen gas produced in experiment 1.
Acid P is nitric acid and the chemical equation for the reaction is zinc plus 2 mole of nitric acid produce 1 mole of zinc nitrate and 1 mole of hydrogen ion. Number of moles of zinc is 0.04 mole and number of moles of nitric acid is 0.1 mole. 1 mole of zinc equal to 1 mole of hydrogen ion, so if 0.04 mole of zinc equal to 0.04 mole of hydrogen ion. The formula to find the volume is number of moles multiple molar volume, which is 24 dm cube. So, the maximum volume of hydrogen gas produced in experiment 1 is 0.96 dm cube.
Next, B. Diagram 9 shows the graph of the result for experiment 1 and experiment 2.
So, refer to the graph before this. The gradient of the curve for experiment 2 is steeper than experiment 1. So, rate of reaction in experiment 2 is higher than experiment 1. Concentration of hydrogen ion in experiment 2 is higher than experiment 1. It is because experiment 2 used sulfuric acid, which is strong diprotic acid, and experiment 1 used nitric acid, which is strong monoprotic acid. The number of hydrogen ion per unit volume in experiment 2 is higher than experiment 1. Frequency of collision between zinc atom and hydrogen ion in experiment 2 is higher than experiment 1.